Welcome back. Today, we're demystifying something that's highly specific but absolutely crucial when it comes to environmental regulation, EPA Performance Specification 7. If you're out there operating an industrial stationary source, or honestly, if you're just fascinated by the nuts and bolts of how we regulate hazardous emissions, you are definitely in the right place. We're going to break down the exact test procedures required for monitoring hydrogen sulfide so you know exactly what this document actually demands.
Okay, let's dive into this. Here's our roadmap for today's explainer. First up, the scope of Performance Spec 7. Second, core equipment testing rules. Third, critical safety and health, and we'll wrap up with reference methods and sampling.
Section 1. Scope of Performance, Spec 7. Let's lay some foundational groundwork. All right, first things first, let's make sure we're totally on the same page about the equipment we're dealing with today. This entire specification revolves around something called H2S CEMS. That stands for Hydrogen Sulfide Continuous Emission Monitoring Systems. Basically, these are highly specialized automated systems that get installed at stationary sources. Think places like oil refineries or fuel gas combustion devices. Their job is to constantly monitor the exact amount of hydrogen sulfide gas that's being released into the atmosphere.
Now, a really crucial point is understanding exactly when the specification applies. Performance Spec 7 evaluates whether your CEMS is acceptable right at the time of installation, or very shortly after. It's essentially your initial pass/fail test. But on the flip side, it explicitly does not evaluate the installed performance of your system over an extended period of time. So it's really just a snapshot, a starting line, proving that your newly installed or recently modified equipment actually works the way it's supposed to right out of the gate.
And the EPA is super clear about this. While this specification is built purely for those initial evaluations, the facility operator is still completely on the hook for the ongoing calibration, maintenance, and operation of the system. You definitely can't just pass Performance Spec 7 on day one and then magically ignore your equipment for the next 5 years.
And that leads directly into how the regulatory oversight works here. Because it's not just about slapping the equipment in and doing a quick daily check. The EPA administrator actually retains sweeping authority under Section 114 of the Act. So what does that actually mean for you as a facility operator? It means the administrator can legally demand that you run these rigorous performance evaluations at other times, entirely separate from that initial installation test. Operators literally have to stay vigilant around the clock, because a surprise evaluation can be mandated at any time to prove that ongoing compliance is actually happening.
Moving on to Section 2, Core Equipment Testing Rules. Time for the strict numerical rules.
So how do you actually prove your system conforms to Performance Spec 7? Well, acceptability basically comes down to two main procedures. Facility operators have to pass both the Calibration Drift test, or CD, and the Relative Accuracy test, or RA. You can think of Calibration Drift as testing the system's consistency day over day, whereas Relative Accuracy tests the system's absolute truthfulness against a known trusted standard.
Let's look at the first big hurdle, the 5% threshold for calibration drift. The spec mandates that your CEMS calibration absolutely must not drift or deviate from the reference value of your calibration gas by more than 5% of your established span value. And you've got to maintain this incredibly tight tolerance for 6 out of 7 consecutive test days. So say your established span value is 300 parts per million for a fuel gas combustion device. Your system cannot wander off that mark by more than 5% day after day. It proves your machine can hold its tune.
Then we have the second major rule, relative accuracy. Your RA has to be no greater than 20% when you're using the average reference method value to calculate it, or, alternatively, no greater than 10% if you're using the applicable emission standard for your calculation. This test essentially proves that your continuous monitor is giving you numbers that actually match up with proven manual reference sampling methods. If you're off by more than 20%, well, your system is basically flying blind, and you fail the specification.
I know we're chewing through some pretty heavy technical ground right now, but before we get into the safety protocols, if you're finding this explainer helpful, go ahead and hit that subscribe button right now. It ensures you never miss out on the visual breakdowns we put together to make these dense regulatory topics actually manageable.
All right, Section 3, Critical Safety and Health. Let's talk about hazardous materials.
The EPA definitely does not mince words on this one. I want to read this direct quote straight from the source text, just to ground us in the real-world dangers here. It says, "The procedures required under this performance specification may involve hazardous materials, operations, and equipment." When you're testing these systems on industrial stationary sources, you are very often working in incredibly volatile environments. This isn't a standard desk job, folks. The physical risks are very, very real. But here's the catch, and operators really need to pay attention to this. The EPA explicitly points out that this performance specification does not address all associated safety problems. Sure, they give you the testing parameters for the equipment, but they are absolutely not handing you a comprehensive safety manual for your specific facility within this document.
Instead, the document explicitly puts the burden of safety right back on the user. It is entirely the responsibility of the facility operator to proactively establish the appropriate safety and health practices. You must consult your specific CEMS user's manual, and you have to review the reference method materials for specific precautions and limitations before you even think about performing any of these procedures. You just can't rely on Performance Spec 7 to do the safety work for you.
Which brings us to Section 4, Reference Methods and Sampling. Time to cross-check that data.
Now, what's really interesting about this is how the EPA handles the sampling strategy. Unless it's otherwise specified in a totally different subpart of the regulation, Methods 11, 15, and 16 are your standard, permitted reference methods for this performance spec. These are the absolute gold standard manual sampling methods that you must use to cross-check your automated system.
Let's break down exactly what those reference methods entail when it comes to time and frequency. For Method 11, which is an integrated sampling method, a single run has to consist of a measurement lasting at least 10 minutes, collecting a very specific volume of sample, and each sample must be taken at approximately 30-minute intervals. Now, if you're using Methods 15 and 16, a single sampling run is going to consist of 2 injections that are equally spaced out over a 30-minute period. You have to match these exact timing protocols to get valid, usable reference data.
And tucked right inside these sampling methodology instructions is a massive, literally life-saving warning. When you're out there pulling these samples, you must exercise extreme caution regarding explosive or flammable sources. The specification expressly forbids using heaters or any non-approved electrical probes around these volatile sources while sampling. Because think about it, a single spark from a non-approved probe during a 30-minute run could trigger a catastrophic explosion.
And that wraps up our structured breakdown of EPA Performance Specification 7. We've walked through the scope, those strict 5% and 20% testing rules, the very serious safety responsibilities, and the specific reference methods you need to use. But I want to leave you with a provocative question to chew on. With your initial PS-7 evaluation completed and passed, how are you going to ensure your facility actually maintains that accurate calibration and compliance for the long haul? Because remember, passing this initial test is literally just day one of your ongoing environmental responsibility. Keep learning, keep monitoring, and I'll see you in the next explainer.